Hello, everyone. I'm Li Qian Ma from KU Leuven. Our paper is Disentangled Person Image Generation. Our motivation is to learn image generation model for person images that explicitly represents the foreground, background, and pose. The task is to synthesize the person images while independently controlling the three factors. Our model can be learned in a self-supervised way, which means we do not need any paired training data. How to do this? We first disentangle the person image into the three factors and then combine them together with the reconstruction pipeline. The previous pixel-to-pixel paper deals with the image-to-image translation problem with the conditional GAN, and then the cycle GAN extends it into an unsupervised method with a cycle consistency constraint. Both of them focus on appearance transfer. Then the PG square network provides the explicit body structure transfer for person image. It is learned in a supervised way. We propose the framework for both appearance and structure transfer, and our model can be learned in a self-supervised way. We have two stages. In the first stage, we learn the embedding feature space with the reconstruction pipeline, and it is the self-supervised way. Then in the second stage, we only train the mapping functions from the Gaussian space to the learned embedding feature space, so that during testing, we can sample the embedding features from the Gaussian noise, and then decode the features to the images. We do the sampling in two stages. Why? Because the person image is very complex, and it's not easy to sample the images from the Gaussian noise. Now let's see some results. First, the sampling results. The top part shows the result on the person re-identification dataset. We can sample the foreground, background, and pose separately or jointly. The bottom part shows the results on the high-resolution deep fashion dataset. We can sample the novel clothes styles and person pose from the noise. One interesting experiment is inverse interpolation. We first use the gradient descent to find the corresponding Gaussian code in the Gaussian space, and then we do the linear interpolation in the Gaussian space. We can inference the reasonable interframes between two real images of the same person or different persons. As to the person re-identification dataset, we can control the disentangled three factors. We fix the foreground and sample the background and pose to get different images of the same person, so that we can generate a virtual dataset. With this dataset, we can benefit the unsupervised person re-identification task. As to the person pose transfer task, our self-supervised method can achieve comparable performance compared to the supervised method, PG square network, and we can generate more realistic images. Given the sequence of the target pose, we can also do the person video generation. Here we show the results of cross-person pose transfer. That is to use the person B's pose to drive person A's appearance, and vice versa. If you are interested in our work, please come to our poster at B20. Thank you.